Hello students. As a quick review of graphing lines and writing equations of lines, I thought I'd take a look at a problem. And I would like to go through it real quick and show you a couple different things that I think are important to know. Now, on this line so far, we have a line graphed, right? And so if we have this line graphed, there's a couple things that we should be able to know what to pull off of it. The first thing we should be able to know is how to find slope, which we said is m, right? And how do I find slope? Well, I pick any 2 points along the line. So for example, I'll pick this point right here and this point right here. They're along the lines. And I have to find slope as a fraction. It's a ratio comparing vertical, how much it goes up. So in our case, it goes up 1 to 3 units, and how far it goes over, which is 1. So rise of 3, run of 1. Okay, so we know that this slope, another way we could write it would be just to write it as 3. Okay, so our slope from this line is 3. The next thing I should be able to pull off is, what is my y-intercept? Okay, remember we called this b. What's the y-intercept from this one? Well, I look to my graph and I see where it crosses the y-axis, which is at 1. Okay, it's the point 0, 1. And so if I know both of them, y-intercept and b equals 1, I can write the equation of my line in slope-intercept form. Okay, so slope-intercept form for this one would be y equals m, which in our case would be, I'll actually write it mx plus b. So in our case, it's going to be y equals 3x plus 1. Okay, starts at 1 and goes up 1, 2, 3, and over 1. That's how we know that this is the equation of a line. But this is in slope-intercept form. And that's important to know. But maybe you're not asked to write it in slope-intercept form. Maybe you're asked to write it in point-slope form. Okay? Well, point-slope form is just another way of writing our equation. Remember, point-slope form was this: y minus y1 is equal to m times the quantity x minus x1, right? And so if we're looking at this line in red, let's say we're asked to write it in point-slope form. Okay, well, I need to have a point. Well, we can pick any point on the line. In fact, why don't we pick this point right here, which is the point 2, 1, 2, 3, 4, 5, 6, 7. So this is the point 2, 7. Okay? So a point 2, 7 has an x1 and a y1. And since it has an x1 and a y1, we can actually use it in point-slope form. So let's do that. So we're going to actually just write it as y minus, well, our y1 is 7, so y minus 7 is equal to the slope, which is 3, still the same slope, x minus 2. Okay, so that's point slope form. But what if they asked us to write this in slope-intercept form and we didn't know this, and we didn't see the graph, and we just had a point and a slope? Well, I'll show you. We can actually manipulate this by first distributing the 3, and I get y minus 7 is equal to 3x minus 6. Now it looks pretty close to slope-intercept form, but I still have that minus 7 on it. So what I do is I can add 7, and I add 7, and I end up getting y equals 3x, and negative 6 plus 7 is 1. So you'll notice that I get the same graph, or the same equation in slope-intercept form, y equals 3x plus 1. So I wonder, is it possible to get another, or the same equation, y equals 3x plus 1, if I picked another point? Well, let's try it out. Okay. So, actually, we'll continue to look at this graph. Let's pick another point along the line. Okay. Okay. Another point along our line. Let's say we pick this guy down here. Well, this is the point negative 2, negative 3, 1, 2, 3, 4, 6, 7, 8, 9. Okay, so negative 3, I guess this would be 8. Yep, so that's a point negative 3, 8. Okay, so now I have another point, negative 3, 8. I still use the same point slope form, y minus y1 is equal to m times the quantity x minus x1, right? And so I have this, which has an x1 and a y1, right? And so I just plug them in. My slope still remains to be 3. Okay, so it'd be y minus 8 is equal to 3 times the quantity x minus a negative 3. And so you'll notice because it was minus a negative, I can just do adding, right? And so I again distribute my 3 and I get y minus 8 is equal to 3x plus 9. Oh, this is supposed to be negative 8. There we go. That makes more sense. And so now I can subtract 8 from both sides, and again I get y equals 3x plus 1. So what we've shown is that it doesn't matter the point that you pick on the line. As long as you have the correct slope, you can find the same equation in slope-intercept form. Okay, so that's when we have an example, when we have a line that's already graphed for us. But let's say, for example, we don't. And instead we just have 2 points. And we're asked to find the equation of a line. So a line containing points 2, 8, and -3, -4. Okay, so I just made this up off the top of my head, but we can find the equation in slope-intercept form and point-slope form. Okay, so let's start with the slope. Well, if we want to find slope, it's an equation. It's y2 minus y1 over x2 minus x1. Now, I want you to stop and ponder. Why do you think it is that we mistakenly want to put x on top? Why is that? Well, for the most part, I think that the reason we want to put x on top is because we think in a point, x comes first and y comes second. So we do the top first, so we think x should go on top. But we need to make mental note that y's go on top. Remember, that's the vertical change. Right, vertical change. And the x is our horizontal change. Okay, so vertical change versus horizontal change. And we know that that's important to know that the y's are on top and x's are on bottom. So in our point that we have listed, in our points, excuse me, we have an x1 and a y1 and an x2 and a y2. So I'm just going to plug those numbers in. I get -4 minus 8 over -3 minus 2. And when I do this, -4 minus 8 is -12 on top. And -3 minus 2 is -5 on bottom. So that actually reduces just down to 12 fifths. Now you could reduce that into a fraction or into a decimal, no simplified, but I guess it could be a mixed number. But the problem with doing that is it doesn't help us when it comes time to graph. So I think it's important to leave it as 12 over 5. I think that's a really useful tool to have. So now we know our slope, right? We know our slope is 12 over 5. So let's keep that right here. So we know our slope is 12 over 5. We found that, right? Now, if we know our slope, to find the equation of a line, we can use point-slope form, right? Which is, as a reminder, point-slope form, y minus y1 is equal to m times the quantity x minus x. Right? So let's plug using our slope and our points, right? So the first thing we have is y minus our y1. We'll just use this point because it's x1, y1 labeled already. So y minus 8 is equal to 12 over 5, our slope, x minus 2. Okay? So if they ask for it in point-slope form, we're done, right? That's the equation of a line. But they're not asking it for that. They're going to ask for it in slope-intercept form, which is common. So what we're going to do is we're just going to solve it, right? So we start by distributing the 12 fifths. And we get y minus 8 is equal to 12 over 5x minus, and how do I multiply fractions? Well, I think of them as improper fractions. And so 12 over 5 times 2, or negative 2 over 1, is 24 over 5, right? And so when we do this, we can add 8, and I'm going to add 8. How do I add a whole number to a fraction? Well, if I think of this as 8 over 1, I can actually add and have a common denominator, which would be over 5, right? So 8 times 5 is 40 on top. And so what ends up happening is we get y equals 12 over 5x, and then negative 24 plus 40 is going to be plus 16 fifths. So that's our equation in slope-intercept form. Now here's something I want to show you. Let's say, for example, instead of using the point 2, 8, we use the other point, negative 3, negative 4. Do you think we'll arrive at the same y-intercept or slope-intercept form? All right, well, let's see. I wonder, right? Y minus, let's see, in the new one, y2 would be negative 4 is equal to 12 over 5, which we've done before, times x minus a negative 3. Okay, so I get this. So far it looks a little different. We distribute the 12 fifths to both numbers. And when I do that, I end up getting y plus 4 is equal to 12 fifths x plus 36 fifths, because remember, 3 over 1. Now I need to subtract, right? I need to subtract. So I'm going to subtract 4 over 1. And so when I subtract this, again, I want common denominator of 5. So 4 times 5 is 20 over 5. And when I simplify, I get y equals 12 over 5x, and then 36 minus 20 would be 16 fifths. So you'll notice that it doesn't matter which one I do, both of them arrive at the same slope-intercept equation. So I hope this helps you out a little bit if you were struggling with graphing or anything from section 3-4. Hopefully this helped you out quite a bit. If you still have questions, make sure you email me, or in the live chat tomorrow, you're more than welcome to ask those. All right? Hopefully this helped.